Let's get started by talking about the in operator. And so in Python 101, we learned about comparison operators, and I just made this bigger. And a comparison operator simply looks like if something is equal to something else. Now, if you took Python 101, we had a little project where we wrote a rock, paper, scissors program. I'm just going to change this to a Python file here. And we saw something like if my answer is equal to rock, and that's actually does not equal rock, and my answer does not equal paper, and my answer does not equal scissors. If I make that just a touch smaller here, exit the program. And that's all it did. Now, there's a better way to do this because we know that the three answers that we're comparing to, rock, paper, and scissors, are all going to be, well, they're going to be the same. They're never ever going to change. So what we can do is this in operator, this in comparison operator. And so what I'm going to do here is view my terminal. And if I type Python 3.9, because that's the version I want to use here, I can simply write the in operator to compare one thing against an array or a list. And so I could say a list of names is equal to, and let's just make this way bigger here. A list of names is equal to Caleb, John, and Gully. And so if we do names, or if we do type of names, we're going to see that this is a list. And it's supposed to be names, names plural. There we go, that's a list. We don't see anything new. We should be familiar with the data type of a list already. But what if we wanted to check to see if a variable or one name is in a list of names? Well, currently what we have to do is for name in names, if my name, whatever that variable is equal to the name, print, this is the name. And so this is kind of, honestly, no way to live your life, because what if your list, what if your array is really, really big? What if you have 1,000 items in there? Then you have to iterate over 1,000 different items just to find out if something is in there. Python has this built in. So what I'm going to do here is Control-C just to cancel. And I can say Caleb as a string in names, and this is going to come out as true. I could also say the same thing with a lowercase k, and this is going to be false because our names has Caleb, John, and Gully. But remember when we're comparing strings in Python 101? A string with a capital K is not the same as a string with a lowercase k. It's not the same with a J or a G or any other letter. The fact is that it has to be an exact match. And so in the first example here, this is an exact match. And what I can do here is, if I just type that out once more, I can say if Gully in names, print Gully is in the list of names. And we see that Gully is in the list of names. And so this is a really, really easy way to check to see if one answer is in a number of answers, a possible number of answers. And so if we go back to our example here, I'll just move that down a little bit and make this a wee bit smaller. If we go back to this answer here, we're going to say if my answer is not rock, if my answer is not paper, if my answer is not scissors. What I can say instead is if my answer, whatever that is, and instead of equal to or equal to, we can say in a list of options. And so we just need to pass this in a list, and we can simply put in a list of options. And let's actually make these variables exist. So we can say my answer is equal to rock. And let's make the options to be a list of rock, paper, and scissors. And now we can say if my answer, rock, is one of these three, then do something. we can say print rock is one of the possible options. Now let's go ahead and save this file as the in operator. And I'm gonna just get out of that. And I'm gonna type Python in operator.py. And it says rock is one of the possible solutions. Now, what if I changed that? What if I changed it from rock to something else? Literally anything else. We could say something underscore else, and we're going to see that this no longer prints anything for us. And that's because if there were an else statement, this would be executed for us. Print, wrong answer, try again. And let's try this out, and we see wrong answer, try again. Now, where this gets a little bit more powerful is, and again, we touched on this in Python 101, so this is a little bit of a recap. Instead of saying my answer is equal to a hard-coded value, we could say input, what is your answer? And if that answer is equal to rock, paper, or scissors, then it's going to say that one of these is an option. We can say that option is a viable option. Otherwise, it's going to say wrong answer, try again. So let's save that and let's give this a shot. It says, what is your answer? If I type in rock, no, let's not do rock. We did rock already. Let's do paper. That option is a viable option. Let's try this again. It says, what is your answer? My answer is going to be Python. Python, I guess, because I put a Z in there for some reason. And it says, wrong answer, try again. And so the in operator, just in, simply says, is the thing on the left inside of the iterable on the right? If it is, if it's true, then execute this conditional statement. If it's not, then it's false, execute the else statement. Or originally we had nothing, so don't do anything at all. Now, if I were to comment that out, we can do the same thing with a dictionary. So let's give a value, not a value, but a variable called key. And this is going to be name. And we could create a person dictionary. Name, Caleb, profession, coding teacher. And then we can say if key in person, print, name is a valid dictionary key in the person object. So let's go ahead and give this a shot now. Let's type in Python space in underscore operator.py, and it says name is a valid dictionary key in the person object. What if we changed key here? What if we change it to just something that's missing? Nothing happens. And that's because what this is looking for is the key. And remember, in a dictionary, we have a key value pair. It's looking for that key in there. And so person with a key of 404 doesn't exist, but person with a key of name does exist. And so we can use the in operator in a dictionary as well. We can also use it in a tuple. Now, what I would like you to do to try this out, to get a little bit of hands-on experience, is I want you to use the in operator on a set. So a set is a Python data type. We learned about this in Python 101. And I want you to use the in operator on a set, not a dictionary, not a tuple, not a list, but a set. I want you to see if that works for you, if it does or does not work for you. Because at this point, we're getting into intermediate level Python. It's time that we start exploring and stop relying on someone showing you everything that can or cannot happen. It's time to start exploring and learning on your own. And so it's really important that you can do this, because eventually you're going to have a job, and in that job, they're going to ask you to create some sort of unique feature, and there's not going to be a tutorial for it. There's not going to be a person to hold your hand for it. You're going to have to sort of experiment a little bit on your own and come up with your own solutions. And this is just really good real-life experience when it comes to just experimenting. And you're not going to break anything, so feel free to experiment. And if it doesn't work, it doesn't work. If you get an error, you can learn what that error is all about. But go ahead and give this a shot. Say if key is in some sort of set data type, then just print something. That's all we have to do. Let's take a look at the not operator. So we learned about conditional statements, and we said something like, if something is equal to something else, do a thing. And that's cool. We also learned about this. If something does not equal something else, do a thing. But what if we don't want to simply write all of that out? Well, we have a shortcut. We can say if something is true, whether that string is true, the dictionary is true, the list is true, the Boolean is true, it doesn't really matter. If something is true, then do a thing. But what if we want to say if something is false? So let's go ahead and set up an example here. We're going to say my thing is equal to true, just to set up this example. If my thing, print thing was true. And if we execute this, we can do Python not operator.py, and it says thing was true. And that's because it really boils down to this. Now, what if we wanted the exact opposite? Well, currently, we have to do this. We have to write pass, and then do an else statement. Print thing is not true. And let's go and change this to false, just so that we can make this execute. So thing is false. This is not going to happen. The else is then going to get executed, and it's going to say this is not true. So if we run this again, sure enough, it says this is not true. Now this is the exact same thing as saying is equal to false, which is the exact same thing as saying is not equal to true. And let's just clean this example up and run this once more. This is going to say this is not true. Because false is not true. In fact, this is not true. The statement is true because it's saying false. Is that the same as true? No? Okay. Well, then it's a true statement. And this is where it gets a little bit confusing. So in terms of Python, we like to shortcut things whenever possible. And we just simply say, if my thing is equal to true, print a statement in here. Now, when we execute this, we're going to see that this simply does not run. This doesn't execute anything whatsoever. What we can say instead is the not operator. So in other programming languages, you're going to see an exclamation mark in front of your variable. You see it a lot in PHP, and you see it a lot in JavaScript. In Python, we don't do that. In Python, we like our code to be nice and readable. So we don't want crazy little symbols all over the place like we have in JavaScript these days. We simply say, if something is not true, and it's literally making a sentence for us. If something is not, and it's always looking for a true value. So if it's not true, aka if this is false, print a statement in here. Let's go ahead and save this, and we're going to see that this now prints out a statement that says, print a statement in here, as we expected. Now let's go ahead and create one more example. Name is equal to Kane Eski. We can say if name not in. Look at this. Now we're mixing the in operator with not. And we have to give us a list of names. Caleb, John, Gully. So if Kane Eski is not in a list with these names in it, print Kane is not part of the club. And when we run this, first of all, we're going to see this print statement up here, so we can just ignore that. But then we're going to see the print statement on line 9. And sure enough, the original print statement shows up from line 4. And then from line 9, it says, Kane is not part of the club. And so what we're saying here is, if the name is not in this particular list or array of names, do a thing. And with the not operator comes a lot of power. We can now check to see if things are the opposite. We weren't able to do that in Python 101. Python 101, we had to take the long way. In Python 201, intermediate level Python, we need to know the not keyword. Is something not true? Is something not in another list? Is something not something else? Now, one thing to keep in mind is typically when we're comparing things like strings, we could have name1 is equal to Kane, name2 is equal to Caleb. Typically, we do not do this. We do not write if name1 not name2 print different names. Because this just doesn't really make sense. If name1 is not name2, I mean, yeah, there is a way to compare using the is operator, like that, but we actually don't do it that way. The is operator is a special one. The is operator means it's comparing pieces of memory, not just the value, which could be Cain or Caleb. And so what we usually say is, when we're comparing strings, if name1 is not name2, and we do it with this operator. But when we're working with the not operator in a list, we put it in the middle. And when we put the not operator in front of something, we're checking to see if it's false. And so if you literally read this, just like a regular sentence, it makes a lot more sense. If something is not true, print a statement. If the name is not in a list, do something. And if one person is not the same as a second person, do another thing. And that is the not operator. Now, what I would like you to do is I want you to do the first two examples here. So let's get rid of this and just do the first two examples. Try checking a Boolean and then try checking a list like this. Make sure you use the not operator in both situations. And the goal here is not to become an expert at the not operator, because it's a pretty easy thing to learn for the most part. The idea here is to simply get some hands-on experience learning how opposite code works. If I'm not part of a club, I can't enter. If I'm not rich, I can't buy a yacht. If someone enters some user input and it's empty, that would be false. So you could say, if not user input, then you can exit the script or tell them to enter more content or re-enter the script. So go ahead and try that out. Again, the goal here is just practice. We just want to practice, practice, practice. That's how you're going to get good. You just need to practice, practice, practice. So try this out, give it a shot. And if you get stuck or this explanation wasn't good enough, feel free to leave a comment down below or in the Learning to Code Facebook group. I'm always there to help out. In the next lesson, let's go ahead and talk about reading files. All right, let's talk about how we can read files. And so we open files in Python with this thing called a context manager. Now, we're not going to get into the details of a context manager too much. It is a little bit of a different way of opening a file, especially if you come from a different programming language. But it is also very memory performant, meaning that you can't accidentally break your computer. And so reading files is as simple as saying with open your file name, R for read, as file, and then we can do something like print file.read, and that's it. That's all there is to it. Now we actually need to create a file in here, so let's go ahead and create a new file, and let's call it readme.txt. Hello from Python 201. That's what this readme is going to say. And so what we're going to do here in this readingfiles.py file, we are simply going to open up that readme file and print out whatever is in there. And so we could say with open readme.txt, that's the file name, comma, R stands for read, as, and then we give it some sort of variable name. We could call it file. We try not to use F anymore because F is sort of short for an F string, so we don't want to get that too confused in Python. So we just write something like file or CTX for context or something like that. It doesn't really matter, it's just a variable name. And then we could say print file dot, and you can see that VS Code is already trying to autofill things for me. So if I just go on down here, I can click read, and this is a function, this is a method. It's actually going to perform some sort of logic, and so it needs those parentheses. Let's go ahead and save that and run this file in our terminal. Let's do Python reading files.py, and it says hello from Python 201. You notice there's actually an empty line in there too, and if we go back here, I'm actually quite certain that there's going to be an empty line too. And yeah, there it is, empty line 2. This is a new line. Let's go ahead and save that. There's an empty line 3. Hello from Python 201. This is a new line. And that's really all there is to reading files. Now, here's the thing, is when you are reading a file or when you're dealing with files, this context manager using the with keyword simply means we don't have access to file outside of this indentation. So if we comment this out and we type pass and then we try to print file.read, let's see what's going to happen here. It says value error, IO operation on closed file. It's trying to read this file, but it's been closed already. So basically what Python's going to do is say, with the readme.txt file open as a reading status, not a writing status or anything like that, just a reading status, it's going to assign that to a variable called file. And then that file is going to be scoped. That file variable is going to be scoped to this indentation here. And then when it gets to the end of the indentation, which it does on line 5, it's going to close that file automatically for us. So we don't have to worry about closing the file at all, ever. Python will do that for us. This is a safe way to open your files. Now, what I would like you to do as a little bit of homework here is go ahead and create a new file called readme.txt and write this out. Do with open and then your file name, comma, R for read as some sort of variable name, and then print that out. And I'm going to clean this up because we don't need that. And then all we do is that variable name, I just happen to call it file.read, and that's going to read the file out for us. So go ahead and give that a shot. Feel free to pause the video right here. There's one more thing I want to show you, but I would like if you could pause the video right here and just try this out. Now, there's one more thing we can do. If we want the contents of this file stored in a variable that's accessible outside of the with keyword here or the indentation here, we could simply say something like content is equal to file.read. And then down here, we can say print the content is content. And when we try this, we're going to see that this works. It says the content is hello from Python 201, this is a new line, and there's an empty line in there. And so now we have access to basically the entire contents of that file, but outside of the context manager that we opened with the with keyword. Now, why is this important? Well, this is important because we have a context manager. We stored the contents of the file in a variable called content, and then behind the scenes, Python closed this file. It did it for us, so it's not using too much memory. It's trying to be as efficient as possible, and because frankly a lot of people forget to close their files, this is a safe way to do it. And then we can access that content variable outside of the context manager. Now, I would also like you to give this a shot. So there's 2 tasks for this particular piece of homework. One is to open a simple txt file and then print it. And another one is to assign the content of that file that you're opening to a variable and then access it outside of the context manager, the with statement, including the indentation. Just make sure it's accessible from outside of that. Go ahead and try that out, and when you're ready, I'll see you in the next video. In the last lesson, we looked at how we can open files and simply read them, but we can also write to files as well. We can create brand new files. And so let's go ahead and create a brand new file from scratch using Python. And so it looks like this, with open, and then your file name. So let's say writing files.txt. So this is the writing files.py file. We're going to do writing files.txt. We're going to create that file. And then in the last lesson, we used R for read. In this lesson, we're going to use W for write as file. So now we have a context manager. So this file is only ever going to be open for as long as we're indenting our code here. Then we can say file.write hello from Python 201. Now let's go ahead and execute this file by typing Python writing files.py, and we're going to see a new file appears over here on the left. And look at that, writing files.txt appears. Boom, it says hello from Python 201. Now what happens when we run this again? Let's write hello from Python 201 a second time, save that, and let's execute this. Now, do you think this is going to append to the writing files.txt file, or do you think it's going to overwrite it? So is it going to say hello from Python 201, hello from Python 201 a second time? Or is it simply going to say hello from Python 201 a second time, as one individual line in this file. These are fun little experiments that we can have while we're learning Python. Let's check this out. Click, and it overwrote the entire file. Now, if you ever want to append to a file, that's really easy. A stands for append. We do A, and this is going to be a second line. Let's go ahead and execute this. Check our writingfiles.txt file, and it says, oh, it's actually not a second line, but it did append to the end here. So it went right to the very end of the file, and it wrote more. What we actually want to do here, and this is a good example, I'm really glad this came up, is we can do /n. And so we don't actually see these in files, but in this file here where that colon is and it goes to a new line, there's actually a hidden character in there. It's a /n for new line. And we can write that new line in here. We can also add a new line and a tab /t. This is tabbed. Let's go ahead and execute this and see how this turns out. So we have hello from Python 201. A second line. This is because I actually messed up. I'm not going to edit that out. I want to show you that even seasoned programmers like myself will make mistakes. It's totally normal. A second line because we ran that a second time. And a tab in here. You notice it's not spaces. This is actually a tab. And it says this is tabbed. So now we can write files. And with this, we can take user input and we can write files directly from user input. But let's not jump that far ahead yet. In the next lesson, let's go ahead and read multiple lines at the same time. So how do we open this file? But then how do we just get this line and then this line and then this line? How do we do that? But before we head on over to that next lesson, what I would like you to do as your task is open a context manager using the with keyword, open a file, name it whatever you like, use the W writing property, so W stands for write, we just put W for short, as some sort of file, and then that context manager file dot write, and then a new line, and you can put a /n for a new line in there if you want, or a /t, and then when you're done that, try appending to that file. So writing is going to overwrite the file every single time. A is going to append to that file, add it to the end. Go ahead and try that out. And when you're ready, let's take a look at how we can read multiple lines at once. Okay, welcome. Let's take a look at how we can read multiple lines at once. Now you might be thinking, well, why is this important? But if I gave you a list of 100 emails and I wanted you to find the one that has my name in it, how are we going to do that? And this is a lot like scraping data from the internet, which is a very, very common thing. So before anything, let's go ahead and create a new file. And this is just going to be called emails.txt. There's going to be email1 at gmail.com, email2, email3, and then let's put Caleb at gmail.com. Let's put John at gmail.com, and let's put Gully at hotmail.com. So we have 6 email addresses in here, and we want to try to figure out if, let's say, Caleb at gmail.com is in here. How do we do that? Well, first we need to open this up. We say with open emails.txt. Let's just read it. We don't need to write to it or append to it as emails. And what we can do here is emails.readLines. And if I print this out, we're going to see that this is going to look very, very familiar. So I can type, let's clear that out. I can type Python reading multiple lines.py. And would you look at that? This all of a sudden is an array. So the first item here is email at gmail.com, email2, email3, Caleb at Gmail, John at Gmail, Gully at Hotmail. This is an array. We can now work with an array. This is exciting because we can take nice shortcuts here. So let's go ahead and throw this into a variable called emails. And we don't have to work within that context manager anymore. Its job is done. We can now access all these emails as an array or as a list, as we call it in Python. We can access all of these emails in a list in a variable called emails. As simple as that. So now we can say for email in emails, print. Looking for, let's say, no, let's look for a Hotmail account. Looking for a Hotmail account. And then we can say if Hotmail is in this particular email, we can use the in operator to check to see if a string is inside of another string. Print the entire email. And so this is going to filter out all of the emails in a file and give us all the ones that have Hotmail in it. Let's go ahead and run this code, and we're going to see, looking for Hotmail account, looking for Hotmail account, looking for Hotmail account. Oh, look at that. I found gully@hotmail.com. Let's go ahead and delete that print statement because that's not useful. Let's say we just wanted all the Gmail accounts. So this is going to filter out the one that said gully@hotmail.com. We run this, and email 1, email 2, email 3, Caleb, and John. Now, what's up with that spacing? Well, that spacing is because if I scroll back on up, you notice that /n. And we talked about this in the last lesson. /n means new line. And so what we want to do here is we want to take this email and we simply want to trim it. Now, in other programming languages, we use the word trim. In Python, we use left trim or right trim. And we don't call it trim at all. In fact, we actually call it strip. So rstrip. And all that's going to do is take out those lines in there. So if we run this again, we're not going to see all those extra spaces. And in fact, that's actually not where we want it to be because we're printing it. This is not going to print anything out for us. We want to change what's being exposed in our terminal. So we do rstrip here. And when we run this once more, let's get rid of that hover there. We run this once more. There we go. It's getting rid of that extra line for us. And again, the reason that's happening is because if we print all these emails, we're going to see that this array here, this list, this Python list, has /n at the end. And that's because at the end of each line, there is a /n. It's an invisible character. We don't see it. But it is there, and that tells the program, that tells the computer that there's a new line here. And so all we're doing is saying, hey, instead of having /n there, strip it out. Now, what I would like you to do as your task is something a little bit easier. Try just opening a file called emails.txt, throw a bunch of emails in there, make sure it's readable, and then I simply want you to loop through every email and print the email. Try this out. And if you notice you have extra lines in there, try using rstrip. That's simply going to get rid of the /n at the end of every value. Go ahead, do me a solid, try that out. It's not gonna seem like this is actually super useful at the moment, but when you get into web scraping, which is what Google does, Google scrapes every single website on the internet and indexes it in a database. It's looking for strings inside of strings. It's looping through every single page out there. So instead of looping through every single email, it could be every single website. And then it's going to do a thing. And that could all be stored in a single file. So that's a fun real world example. Yeah, definitely try it out. And when you're ready, let's head on over to the next lesson where we actually ask a user for some user input and then create a file that's then going to be executable. Okay, welcome back. Let's talk about executing files, or I guess creating files from user input. And so the idea here is that you can ask a user for some form of input, and then you can create a file out of that. And with that file, you can add some content in there as well. So let's merge all the experience that we have with reading and writing and appending files into a program where you can basically create your own form of catalog or contact book or address book. So first, let's ask for a file name. File name is going to be input. What is the file name? And let's also ask for content. Input is equal to enter the content, whatever that content is going to be. Then we can say something like with, we're opening a context manager here, open, that file name, we're going to write or overwrite it every single time as file. Then we can say file.write the content. Now, if we try this out, Python executable user files, it's going to ask me for a file name. So let's put zzz.txt just so it shows up at the very bottom here. It's easy to spot. Enter some content. Hello, my name is Bob, and I like to code. Okay, looks like it did nothing, but hey, check that out. zzz.txt showed up, and boom, my text is now in there. Now get this, we can actually start making this a lot more enjoyable for the user. We could say, open file is equal to input, would you like to read this file? And this should take a yes or a no, so we could say if open file is in Y or N, then we can do a thing. We say if open file is equal to N, do nothing. Or we can say if the open file is equal to Y, let's go ahead and open this file now. So we can say with open that same file name from above with reading properties as file print file.read. And so the whole script looks like this. We're asking for a file name. We're asking for some content. We're then going to write that file name with content inside of it, and it's completely dynamic. It's up to the user. Then we're going to say, would you like to open this file? Yes or no? If open file is in a list of either Y or N, then execute this code. If open file is equal to Y, then we want to open this file and print that file out. Let's go ahead and give this a shot. Let's do yyy.txt as the file name. Enter some content. Content is king. Remember when people used to say that on social media? Content is king. And would you like to read this file? Let's type Y. And it prints it out for us. It read that file for us. And that's exactly what's in yyy.txt. Now I'm going to delete this file. I'm going to delete this file as well. And I'm going to leave this source code with you. Now I want you to try this out. Just try out lines 1 through 5. You don't have to worry about lines 7 through 11. We're just getting fancy there. We're basically showing off our skills just because we can. Which is a very programmer thing to do. We like to do that. But try this out. Ask for a file name, use some user input. Ask for some content, use some more user input. And use a dynamic file name. And dynamically write some dynamic content. And then make sure that file actually shows up where you think it's going to show up and open it up. Make sure that it's doing what you expect it to do. And if everything is looking good and looking right, let's move on to that next lesson where we talk about functions inside of functions. Because, surprise, surprise, everything in Python is called an object. Yeah, it's a mind-blowing concept, but we can nest things within nest things, and you can actually see it here. We nested a with statement inside of an if statement inside of an if statement. This can go on forever. It's not performant to do that forever, but we can do that forever if we wanted to. And functions are no different. We can have a function inside of a function inside of a function. So the next lesson we're going to take a look at functions and some of the weird scoping that happens inside of that. Let's take a look at functions nested inside of functions, because in Python, we can do that. In Python, everything is called an object, and that means functions inside of functions are objects, files are objects, packages are objects, everything's an object. You get an object, I get an object, we all get an object. But in this course, not in this course, but in this lesson, let's take a look at scope and how it affects functions inside of functions. So let's create a function. Let's call it thing1. And then we can have a function inside of this. And let's just say print welcome to thing1. And let's tighten that up just a quick sec there. And let's have another function here, thing2. Print welcome to thing2. And to execute this, inside of this function, or rather to execute thing2, we simply execute it inside of thing1. So we say thing2, execute it, and then when we call thing1, this is going to execute, it's going to print, it's going to then register this function and the code inside of this function, and then execute that function inside of it. And so now we have two functions in one here, and it's really only required to call one of them. So let's go ahead and save this, and let's go to View, Terminal, and let's type Python executable user files. That's not right. That is I gotta undo that. All right, so I just changed the name of that file there, so we're not overwriting the file from the last lesson. So what I want to do here in my terminal, type Python functions inside of functions, and we're going to see it says welcome thing 1, welcome to thing 2. And that's again because if we separate this, it might make a little more sense to our eyes. But thing 1, well, we know that's a regular function. Thing 2 is then going to register or be registered inside of thing 1, and then we executed it. Now, if we didn't want it to be executed, well, why would we write it at all? But that's beside the point. We could just simply not execute it inside, and this is simply going to say welcome to thing 1. So that is a function inside of a function, and ultimately that is what is called a decorator. A decorator, something like that. That is the premise of a decorator. We'll talk about decorators probably in a future course or a future module, but that is basically what a decorator is in Python. So now let's take a look at scope. Let's say thing 1 takes a name, but thing 2 is not going to take a name. So we could say welcome to thing 1, comma name. And how are we going to pass thing 2 that name? Well, we could also do this. We could say name, and then we could say name in here. And then if I said Jacob, this is going to say welcome to thing 1, Jacob. Oh, we need name in there as well. And so it passes the name along. But honestly, having to type that same variable name over and over and over again is irritating. You see how many times I have to type name here? The nice thing about Pythonic scoping is if it doesn't find a name inside of this function, if it doesn't find this particular name, and this could be called literally anything, but if it doesn't find that variable, that parameter, that argument inside of its function, this is going to look outside of the function. It's going to look into thing 1 for a variable called name. And so let's go ahead and test this out. And let's not pass in name whatsoever. And so thing 2 is going to say welcome to thing 2. It's going to have a name in there, but we're not actually passing anything in. And so we see this a lot in the world of JavaScript, but we don't see this a lot in the world of Python. Let's go ahead and execute this, and we're going to say what? We're going to see that it says welcome to thing 1 Jacob and welcome to thing 2 Jacob. And that's because even though we didn't pass in explicitly the name parameter, what it did was look for a name inside of this particular function. It didn't find it, so it looked just outside of that function. It found it inside of function thing 1. And the nice thing about this is it's scoped so that if we tried to print out here, print name, it's not going to exist whatsoever. In fact, this is going to throw us an error, name error. The name is not defined. And that's the nice thing about functions and scoping with functions is that once you have a function, if you have a nested function, you can use all of the same variables from that original function. And that original function, i.e. in this case, thing 1, is not going to leak out any of its parameters or any of its arguments. And so that keeps your namespace nice and clean. So we don't have to worry about name being registered and magically or mystically doing something when simply it doesn't exist. All we've said was, basically, if you package this up, you don't see name is equal to anywhere in here. It doesn't exist out here. And that is Python scoping. Now, that's just regular Python scoping. That's just how Python works. If it can't find a thing, it looks just outside of that thing. And as a recap, functions inside of functions is really you just declare a function, declare a second function inside of it, or a third, or a fourth, or a fifth function inside of it. You can do a thing, you can return a thing, you can do pretty much anything you like inside of that second, or third, or fourth, or fifth nested function. And you can just keep nesting away if you want to. Just you have to remember, whatever function you register, you have to execute as well. And so if you're thinking, well, why would I even do this with one print statement? Honestly, you wouldn't. But if you had 10 lines of logic in here and you wanted to reuse that logic 2 or 3 times inside of thing 1, you would register that as a sub-function. Now your task for this lesson is to give this a shot. Create a function, nest a function inside of it, execute the nested function, execute the original function, and make sure you pass in some sort of argument or some sort of parameter that gets used in both the original function and the nested function itself. Go ahead and give that a try. When you're ready, let's head on over to the next lesson where we talk about making simple API requests. Let's go ahead and make a simple API request. All right, in this lesson, we are going to need to use a package called requests. So first of all, let's try this out. Let's type Python to get into our shell, Python, if I can spell that, and then we can just type import requests. And if you don't see any errors, then you are good to go. We can proceed. We can use requests. If you see an error, something like this, import requests to, if you see a module not found error, then we have to go ahead and install requests. Now, if we have to install requests, that's fine. We can do that. Let's just quit our shell here. And you're going to need to have pip. Now, you should already have pip installed on your computer. If you type pip-v, it will tell you a bunch of stuff in here. And my pip is using Python 3.8. Now, if you do not have pip installed on your computer, if this command doesn't work for you, head on over to the lesson where we install pip. And we talk about packages and things like that, and then come back to this one. So that's a few lessons ahead, and then just come on back. But modern versions of Python, if I recall correctly, comes with pip by default. So what we can do here, assuming you have the requests package or module, you can import requests, and then you can simply say req for request is equal to requests.get and then some URL. So let's do https caleb.io, and we can print the status here, x.status code, and not x. I'm used to typing x, it should be rec. I just changed the variable name there. Print rec.status code. And let's go ahead and give this a try. Python simple API requests.py. And it gives me a 200. Now a 200 status in HTTP codes means the site is up and running. Now at this point you can make a site monitoring program quite easily. We could do something like this. Let's go ahead, comment that out, and we can do import requests, import time, while true, req is equal to requests.get, and then your website, so https courses.coding for everybody.com, print rec.status code, and then we can say if that rec.status code does not equal 200. We could send an email, we could alert, we could break out of this script, we could do anything we want. So we're just going to pass, but ultimately this would ideally send an email, send a text using Twilio API, something like that. Email me or text me, something like that. And this is going to run very, very quickly over and over and over again. So we don't want to spam our server with requests. Instead, what we want to do is make one request and maybe wait for like 60 seconds. And so we could do time.sleep 60 seconds. And so once a minute, this is going to make a request. But just as an example, let's lower that down to like 3 seconds. And let's run this again and see what happens. 200. 200. So we're going to see that this is constantly polling my site to make sure that it's up all the time. Basically, we just created an uptime program or an uptime monitoring program in like 7 lines of code with Python. And so to cancel, all I did there was Control C. So I'm going to actually comment out this one. You can check out that source code if you like. And I'm going to uncomment the original one because that's all we really need to do. For this particular lesson, all we need to do is this. And this is a simple API request. In fact, actually, this is hardly even an API request. This is more or less just an HTTP request, but in Python, it's so close to an API, it's basically an API request. In the next lesson, we're going to take a look at making an API request to an endpoint that actually accepts JSON, or not accepts, but returns JSON, and how we can turn that into a Python dictionary and work with that data. But for now, go ahead and give lines 1 through 4 a try. Just try it out, have some fun with it. See if you can get a different status code from a different website. And if you get a different status code, something that's not a 200, feel free to go and research what that status code means if you're not familiar with HTTP status codes. All right, let's make a JSON API request, just a simple one. So we're just going to get some information. We're not going to post any information or put or delete or any other API term. We're simply going to get some information. And this is going to be the most common thing that you do when it comes to Python APIs, or APIs really in general. So from the last lesson, we did import requests. And then we said req is equal to requests.get, and then some URL in here. And we don't know if that turned out to be HTML or JSON or anything like that. So we need to find an endpoint. So if we head on over to swappy.dev, this is one of my favorite API sites because it's themed for Star Wars. And I like Star Wars. But we can also go to swappy.dev/API/ let's say people/1. And this is going to give us information about Luke Skywalker, or people, let's say 6, whoever that is. Owen Lars. And we can get all this JSON information. Now what's nice about this is it's not a lot of information, but it's enough to be a great demonstration. So let's go ahead and get swappy.dev/API/people, and then just a number. So that's going to be our URL, https swappy.dev/API/people. Let's do person2, whoever that is. And then let's say that person is going to be whatever that request turns out to respond with, .json, and print person. Let's go ahead and try this out. Python, making JSON API requests. And it takes a second, and we can see we got C3PO. And if you're familiar with Pythonic data types, this looks a lot like a dictionary, doesn't it? So now we can pull out the name. We can say print name is tab. And let's do a f-string variable in here. So let's say person name. And let's make this an f-string. What else can we add in here? We've got a name. We can also add his birth year is person birth _year. And I'm just getting that from here and here. So let's go ahead and run this once more. Name is C3PO. Birth year is 112 BBY. Let's add one more tab in here, just to sort of line this up nicely. Name is C3PO. Birth year is 112 BBY. And now we have access to all of this information in here. Now what's cool about this is we also have movies, don't we? They're called films, and films is simply a list of films that, let's say, C3PO is in. So let's take a look at where 3PO is in, and let's print out which movie that title is called. So we need to, what is that URL? API films 5. Films/5. Let's request that. And it's called Attack of the Clones, and it's in episode 2. So let's say we just want to figure out which movies he's in. We could then say for film in person films, because this is actually a list. req for request, requests.get film URL, print film is, and then we can do film. Actually, we need to JSONify this first. So let's say film is equal to request.json. And then we can do film title. And this is going to print out all the films for us. Let's also give this a print statement above. Films involved in. And let's run this once more. And it's going off and getting every single film. So this is making a different API request for every film that he's in and getting that title. And so now we're dynamically getting a lot of information. We're getting a character, C3PO. We're checking which videos or which films he's involved in. And for each one, we're getting that data, that whole film data, including the title. And all we're doing is printing the title. And that's why when we do this, you can see that it's coming back one at a time. Film is A New Hope, Empire Strikes Back, Return of the Jedi, Phantom Menace, Attack of the Clones, and Revenge of the Sith. Now, as a heads up, I do actually believe that there is some data missing from this API, but regardless, it's still a fun API to use. So as a recap, how do we make JSON API requests? It's the same as making a regular request, but if that data turns out to be JSON, we can simply do .json on that request object, and that's going to throw it into a variable. We called it person. And then we have access to all of that data, all of this data in a Python dictionary. So what I would like you to do is give this a simple shot. You don't have to do a for loop here, but what you can do is a simple request or a get request, and then JSONify it, and then print out what that data is. It'll come back as a dictionary once it's JSONified, or read from JSON rather. It'll come back as a dictionary, so you can have access to the name or the birth year or anything else that the API gives you. Go ahead and give that a try, and when you're ready, let's talk about how we can convert a string that looks like JSON to an actual piece of JSON and a Pythonic dictionary. Okay, let's take a look at reading JSON. So in the last lesson, what we did was we took some JSON from an API and we just sort of worked with it. And that was fine because the data was actually in JSON format. It wasn't a string, it was in JSON format. And so it was formatable for us, and we could easily turn that into a dictionary using Python. But what happens if this comes back as a string? Now, what I mean by that is just that data from C3PO in the last lesson looks a lot like this. So C3PO is equal to, we'll make this a bit smaller here, and it has all this information in here. Now, we can't simply say C3PO bracket name like we did in the last lesson because this is a string, this isn't a dictionary. So if we say C3PO name and we try to print this out, Python reading JSON.py, we're going to see that string indices must be integers. And that's simply because it's trying to slice this. It knows it's a string, and so it's not a dictionary. It doesn't have a key or a property called name. So we need to convert that. Now we can do that with the JSON library. All we have to do is type, I'm going to make this just a touch bigger there, import JSON, and we have C3PO up here. What we can do now is say C3PO is equal to C3PO, but we simply put JSON.load s, load s. It looks like the word loads, but what it actually means is load string. So we're taking that string and we're throwing it into basically a conversion tool that's going to turn this into a dictionary for us. And if this is properly formatted, we won't see any errors. And so now you're going to see something like this with this particular example anyways. It's going to say something along the lines of expecting property name enclosed in double quotes. And that's because, guess what? This is not properly formatted JSON. This is a dictionary from Python. Now, if we go back here, people/2, let's get C3PO. You can see all this data has double quotes, or not double quotes, but not using apostrophes at least. So let's go ahead and copy that. And let's give it properly formatted JSON, which means we have to swap out the apostrophes we were using. And let's go ahead and use 3, like a doc string, so we can have multiple lines in there. Let's go ahead and try this out. Cool. That worked. So even though it's on multiple lines, it was totally fine. We have C3PO is equal to this giant JSON string. It's not a JSON object. It's not a dictionary. It's a string right now. And then we said C3PO is equal to JSON.loadS, and then that string, this string up here, and it simply converted it into a dictionary for us. So let's go ahead and type print type C3PO. And we're going to see that this is going to be a dictionary. It's going to be a DICT. There it is, class dict. Now, what's cool about this is we can then put this out to another file after we edit it. So let's go ahead and remove that, and let's change something in here. Let's change C3PO's name to something else. So we can say C3PO name is equal to my friend Kane Eski. And now that's only going to change it in the dictionary. That's not going to change it in the actual text here. We need to convert this back. And so to convert it back, we simply do json.dump s, dump string, C3PO. And let's do C3PO underscore string is equal to, and let's print that. Print C3PO str. And this is all of his data. This is coming back as a string, and the name is Kane Eski. We have now taken JSON data as a string, and you're going to be working with this a lot, so it's important to know how JSON works. Not everything is perfectly formatted in the developer world or in the human world at all. And so we took a string, we said convert it to proper dictionary using JSON load s. Then we changed the name. Then we said, oh, actually what we want to do is we want to dump that data. So we changed that name, basically changed it up here. And then we dumped that data back into a string using dump s, dump string, gave it a string, and then printed it. And that's really all we had to do. Now, what I would like you to do is to give this a shot. I want you to try it out. This is really important. You're going to be using JSON a lot. Maybe not every single day as a Python developer, but certainly every week or every 2 weeks. So it's very, very common. Feel free to even steal this code just because it's got the dictionary, or not the dictionary, but the string JSON data in here. Don't forget to import JSON, json.loads, and then again, when JSON is imported, json.dumps. And that stands for load string, dump string. Let's take a look at function arguments. So in the wild, in a lot of Python, especially in like the world of Django, you're going to see something like def, thing, self, request, args, **, kwargs. And so in this lesson, let's take a look at what args is. Because, well, that's going to come with classes, so we don't need self. Request is a Django thing, but this could really be anything. Let's say name. And then it takes some sort of arguments and then some sort of keyword argument. So let's ignore the keyword arguments for now, and let's just work with args. So first things first, when we're working with args, let's get rid of this because we're not using it. If we just dissect this function here, what data type does this look like to you? You should be saying this looks like a tuple. And that's what args comes back as. Args always comes back as a tuple. So let's create a function here where instead of def thing, we're going to say add numbers. And we're simply going to print the args. Now let's get rid of name because that is going to be a positional required argument. We don't want that. We just want to throw in any number of arguments. And the nice thing about args here is that you can pass in an unlimited number of arguments and it will just work. So now let's say add numbers 1, 3, 5, 7, and 9. And let's, yeah, there we go. Now this isn't actually going to add the numbers, but this is going to print out 1, 3, 7, 1, 3, 5, 7, and 9. So function args.py, and it comes back as 1, 3, 5, 7, 9. Let's take a look at this. Let's dissect this a little bit. Let's see what this actually is. Is this actually a tuple, or was I just pulling your leg? Look at that. I wouldn't lie to you. I wouldn't do that to you. It's a tuple. And so any arguments, not positional arguments, for example, if we have a positional argument called name, I'll use Caleb as an example. This name here, Caleb, gets assigned to the first positional argument. Everything after this positional argument is a star arg, or just a regular argument. And so what this is doing is saying, oh, let's match up that first one. And then if we didn't pretend, or if we did pretend that didn't exist, the rest of them would be arguments. And so now we can work with all of these. What's cool about this is we can say total is equal to 0, and if we wanted to add all these numbers, we could say for num in args. Total is equal to total plus whatever that number is going to be. So it's going to add 1, 3, 5, 7, and 9 together. Return total. And then out here we can say the total is add numbers, Caleb 1, 3, 5, 7, 9, print the total. And let's actually get rid of this positional required argument because we're not using it. So why is it there? And let's run this. We get 25. Let's add this together in our heads to make sure this works. 1 plus 3 is 4, plus 5 is 9, plus 7 is 16, plus 9 is 25. And so now we can take unlimited arguments using the args keyword. Now, it doesn't have to be args, it just has to be delimited by that star. And that's how Python knows that this is going to be the rest of the arguments. In JavaScript, I believe we use a thing called a rest operator, so a ... In Python, we use a star or an asterisk, and that simply tells Python that the rest of these functions, or the rest of these arguments in this function, is going to be a set of arguments. And so it knows to package them up, throw them in a tuple called args, and then we can work with all of those arguments. Now, what I would like you to do is give this a try. I want you to create a function where you maybe add all the numbers together, or you multiply all the numbers together, do some sort of basic addition, or multiplication, or something like that. You could even take names if you wanted to. Take a series of names. It doesn't have to be numbers. We just use numbers because it was simple. But you could use a series of names and print out all the names. Regardless of what you end up trying, I want you to try this out because you're going to see star args everywhere in professional level Python. It's very, very important you understand how this works. When you're done that, in the next lesson, let's talk about this thing called kwargs, keyword arguments, and that's delimited with 2 stars. It's a little bit different, kind of the same. Okay, let's take a look at keyword arguments in a function. So often you'll see def thing, a positional argument, a positional required argument. You could have something like a positional optional argument, so name, age is equal to 31 by default. Then you can have some form of arguments in there, any kind of arguments. These don't have a name. These are simply like 1, 3, 5, 7, or 9, like we did in the last lesson. And then we have keyword args. And this is a full function. This is pretty much everything we can do inside of a function in regards to parameters. So we know that name is going to be required, absolutely required. Age is optional. Whether it's in there or not, doesn't really matter. Age is always going to be 31. Then we have args, and this could be any number of arguments. It can be literally an unlimited number of arguments. It comes back as a tuple, and we can loop through the data in that tuple. Keyword args, kwargs, is delimited with 2 stars, 2 asterisks. And what this means is instead of coming back as a tuple, it comes back as a dictionary because keyword args look like this. Thing is equal to something. Or if we do this in Pythonic terms, thing, something. And so it's a little more dictionary-like. So let's go ahead and ditch this and let's create an example where we use kwargs. So def. Let's say a person has some sort of attributes. We don't know what those attributes are yet, but we can loop through them. So first of all, let's print kwargs and print type of kwargs. And let's execute person, and let's say name is equal to Jacob. Age is equal to 27. Brain is equal to huge. And what's great about this is I actually know a person named Jacob. I think he's about 27. And he's probably the smartest person I've ever met. Python function kwargs .py, and we're going to see that we get a dictionary with name Jacob, age 27, brain huge. And all this did was literally package this up and throw these keyword arguments into a dictionary for us. So now we can work with this. We have something to work with. So we can now say, in our function, if, let's check to see if age is in quargs, print your age is, and then we can do quargs.get, because it's just a dictionary. We know how to use the .get method already. Quargs.get name. And so now we're using the in operator, we're using get, we're using dictionaries, we're using a conditional, we're using keyword arguments, we're using a function, and we're using print statements. And name, why did I put name? I should have put age. If you're yelling at your screen going, well, good catch. It says, your are, just one after another here, just killing it today. You are 27. Cool. Let's just pretend I got that on the first try. So now you might be thinking, where is this actually used? Like, this seems kind of far-fetched. And if you're thinking that, you know, you're not wrong, but you're probably not completely right either. A good example of this would be like, let's say you want to order pizza from a website. Def, order, pizza. We need a positional argument, name. We need an address to deliver it to. And let's say toppings. Now toppings is going to be a keyword argument. And so we can say print order is for name. I'm going to use an F string here. And the address is ship it to the address. Now we need to come up with some kind of pricing. So the price right now is going to be, let's say, a default of $18. And for every topping that we have, we want to add another $2 to it. So now we can loop through toppings. We can say for key value in toppings dot items, because we know this is a dictionary and we can simply loop through all the toppings. Now we don't really care what the toppings are. It could be pepperoni, could be ham, could be pineapple, could be extra cheese, could be jalapenos. I don't know. Doesn't really matter. We just want to figure out the price here. And so we're going to loop through all the dictionary items. That gives us a key value pair. And frankly, we don't even need to use the key or value. So the fact that we're using .items is completely useless. It's just good for example code in this video. So let's go ahead and say for every item in here, price is equal to price plus $2. Let's print that out when we're done. The total price is price, and let's return price. So let's go ahead and now order this pizza. How do we instantiate this particular function? We do order pizza, because that's the name. Let's say it's going to go to Amanda. She lives in Canada. And what kind of toppings does she want? Let's say jalapenos is equal to true. It's a keyword argument. Extra cheese is equal to true. And ham is equal to true. And so we've got a positional, let's scroll that up just a little bit here. Positional required argument called name, another one called address. Everything else is considered a keyword argument. So if we order this pizza, we can now say total price is equal to this. Let's go ahead and actually execute this. Python function quargs. And it says orders for Amanda, ship it to Canada. The total price is $24.0, so $24. And that's because we have 2, 4, 6 extra dollars, because every topping is worth $2, and the base price is 18. And this is a real world example of how you could possibly, if you wanted to, use keyword arguments. You could also check to see if address is in the keyword arguments, because if address was in the keyword arguments, you could either ignore it, or if it wasn't a positional required argument like this, if it was in there, then great, you know where to ship the food to, or deliver the food to. Yeah, do we ship food? Do we deliver food? You know where to deliver the food to. Otherwise, if address is not in toppings, and we're simply checking to see if there is a key inside of a dictionary there, if address is not in toppings, you're going to need to ask the user for an address. And this is a real world situation. This is how you would order pizza using Python. Now, I would like you to give this a shot. I'm going to undo that so this code actually works. Go ahead and create a function that takes a couple of positional required arguments, and then let it accept keyword arguments with ***. And again, it doesn't have to be called kwargs, like keyword args. You'll just most likely see it that way. It could be called anything. But more often than not, you're going to see it as kwargs. Go ahead, try it out. You're going to need to know how this works when we move into things like Django, because we use keyword arguments everywhere in Django. In the next lesson, let's talk about how we can install pip. Let's take a look at how you can install pip. So first of all, what is pip? Pip is a package. I guess it's considered a package, but pip basically lets you install third-party packages using Python. So if you've ever used JavaScript, you might have used npm. In PHP, it's called Composer, I believe. Composer. I think it's Composer. It's been a little while. And in Python, we call it pip. And so how it works is we can say pip install package name, and this makes it available on our computer for us. So we can now use other people's code on our computer. Now, if you don't have, for example, requests installed, you can simply do pip install requests. Now let's check to see if you actually have pip installed first. Let's do pip-v in our terminal, and I have pip installed. If you don't have this, if this gives you some sort of error, like command not found kind of error, we're going to need to install pip. Now, if you already have pip installed, and you might already have pip installed just because Python might come with it, if your version of Python comes with pip, you can ignore the rest of this video. If you do not have pip, let's go ahead and install pip now. So to install pip, what we're going to want to do is we want to, first of all, curl this down to our computer. So we want to download this file to our computer. And so we can do that with curl on our terminal, https://bootstrap.pypa python packages.io/get-pip.py. Then we do -o, and we're going to call it get-pip.py. Now let's see if I have any typos in here. Downloading the file. And if I do ls-la, or if you're on Windows, you can write dir. And do we have get-pip? We have a function here called get-pip. Great, that's what we want. So now once you have that file, all you have to do is type python get-pip.py. And that will go ahead and get and install pip on your computer for you. Now that command again is just this. Curl https://bootstrap.pypa.io/get-pip.py-o get-pip.py. So, feel free to pause the video here if you need to, if this isn't available for you on this platform, to basically copy and paste. You can just pause the video and write it out. And then you need to run python get-pip.py. And once that's done running, you should be able to do pip-v. And pip-v is going to show you your pip version, where it's being used. So for whatever reason, my pip version is using 3.8, Python 3.8. And it tells me Python 3.8 in here. Now to install a package is as easy as saying something like pip install colorama. And this is going to go off and download a bunch of stuff. It says it's already satisfied for me. I guess I already have it somehow. And I can uninstall by doing pip uninstall colorama. Yeah, let's get rid of that. Doesn't need to be on my computer, so I got rid of it. Another one you might possibly want, if it doesn't come with your version of Python, is go into your shell and simply type import requests. Okay, that worked for me. But if you see an error that looks a lot like this, module not found error, you're going to need to install requests. So let's go ahead and quit. And you can do pip install requests. And this allows us to then, in our code, what we saw before was like import requests or import JSON. And that just allows us to import other people's code. Now, Python comes with some of its own code, like you don't need the JSON library, it just comes with Python. It's just not part of the core part of Python. So you do import JSON. Whereas requests may or may not come with your version of Python. If it doesn't, you have to do pip install requests, and then we can, in our code, import requests. All right, welcome back. Let's take a look at this idea of something that can be mutable versus immutable. And these are fancy words for is something changeable versus unchangeable. That's all it is. Developers, programmers, we really like our fancy words, so we use immutable and mutable. Really just means changeable and unchangeable. That's it. But there's something to note here, is when you're working with certain variables, certain things are mutable or changeable, some things are immutable, unchangeable. And so, for example, you might be thinking that a string is mutable. It's actually not. It's not changeable. So if we have some sort of string in here, we could say, the fox jumped over the cow. And then we said, string is equal to something else. We might be thinking that this is actually mutable, but what's really happening behind the scenes here is something very different, something you wouldn't necessarily expect. So string here is taking this particular string and is jamming it into a little piece of memory on your computer, and we nicknamed it string. That's the variable name. Now behind the scenes, we cannot change this whatsoever. And so if we did string dot upper, and let's print this. Let's print string.upper, and let's also print just the regular string. And let's do Python mutable versus immutable. We're going to see that one is uppercase and one is not uppercase. And what you actually see here is string is taking all of this, turning it into uppercase, but it's not restoring it back into this particular variable. What it's actually doing is just holding that in memory and then letting you use it. Now, if we wanted to, we could try to overwrite this. We could say string is equal to overwritten. And absolutely, this is going to work for us. But behind the scenes, it's doing something you don't expect. Behind the scenes, it's saying, okay, string is equal to this particular sentence here, and then that string is being overwritten. This has a piece of memory. This has a different piece of memory. So we're not putting this piece into this string and then putting this piece into that same string. We're actually overwriting it altogether. So we're saying this has a piece of memory. This cannot be changed. Once it's in there forever. Or, until your script ends at least. Then we're saying, okay, well, we know that there's a piece of memory called string. We're going to overwrite that with a new piece of memory and call it overwritten. So behind the scenes, you cannot actually change a string. Now that's wild because you would think that you could be able to change a string, but it just doesn't work that way in computer science. So another example of this would be like a list. So we could have names is equal to Caleb, Jacob, Gully, and Amanda. What's different about this is because we're using a list, and even though these strings in here, these individual items are immutable, the list itself is mutable. It means we can change it, we can add to it, we can append to it. So we can do names dot append, and let's add the cat named Rhubarb. Print names, and you notice how we didn't do names is equal to names dot append. We didn't do that. We simply assigned a variable here, and then we said, with that variable, add something to it, and then print that out. Let's go ahead and run this. We see the overwritten example at the first two lines. Then we see Caleb, Jacob, Gully, Amanda, and Rhubarb. And, interestingly enough, unlike this, where we did string.upper, it didn't save it as uppercase whatsoever. We can see that here, it was uppercase once, but it didn't actually save it as uppercase. Whereas names, with a list, it did. We set that variable, whatever that variable is going to be, as a list. Then we said that list dot append a new item, add a new item to that list, and it automatically saved it for us. That means lists are mutable, but strings are not mutable. Now, is this important in your everyday Python life? No, not unless you're going to get into probably data science and you have giant amounts of data and you need to be very performant. In web development, we don't really need to know this, but it's a good thing to know nonetheless. Now, as your homework, what I would like you to do is go off and Google, is a tuple mutable or immutable? We know a list is mutable, we know a string is immutable, but a tuple is like a list that you can't add anything to. Is it considered mutable or immutable? You're going to have to go do a little bit of research for this one. When you're done that, let's head on over to the next lesson where we talk about this fancy word called enumeration. Oakley dokley, let's talk about this thing called enumeration. And really all this is going to do is we're going to loop through some sort of list and we're going to get the index number from it. So we could create a list. Let's say animals is equal to a list of Gully, Rhubarb, Zephyr, and Henry. And then we can say for animal in animals, print the animal. But how do we know exactly which order this is in? How do we know that Rhubarb is going to be number 2? Or how do we know that Henry is going to be the last one? Currently, we don't. And so if we execute this code, we're going to see that this is a standard for loop. We learned about this in Python 101. Nothing fancy, nothing new, nothing exciting. So if we wanted to get the numbering in here, we use this function called enumerate, and we wrap our list in it. And what this is going to do is if we try to run this, check this out. It gives us a tuple. And it's actually every single item in here is a tuple. It's a tuple of tuples, or a list of tuples, rather. And so 0, Gully, 1, Rhubarb, 2, Zephyr, 3, Henry. So now we have those index values. And because there's 2 of them in here, we can do this thing called unpacking. So we can do index and then animal. And then if we print just the animal, it's going to show up just like the first time. We could print index, then that animal. And we can see here, 0, Gully, 1, Rhubarb, 2, Zephyr, 3, Henry. So now we're starting to get that index number. Now we can actually do something with this. We could say, if index modulus 2 is equal to 0, so every second one, continue. And then, if we don't continue, if the index with a modulus of 2 has a remainder of 0 or doesn't have a remainder of 0, print that animal. And so this is only going to show every second one. This shows Rhubarb and Henry. Or as an alternative example here, what we can do is we can print with an F string index plus 1 number. Let's do a tab. Let's not do space tab, let's just do tab. And then the animal. And this is going to look like a proper numbered list for us. 1, 2, 3, 4, Gully, Rhubarb, Zephyr, and Henry. So now we're getting somewhere with this. Now enumerate comes in pretty handy. I use this probably once or twice a week in professional level code. And so you're going to need to know what enumerate does. And really all it does is say, hey, let's give it some index values here. So this is going to be 0, this is going to be 1, this is going to be 2, and this is going to be 3. Simple as that. All it does is add index values, because sometimes you need those index values. Go ahead, try this out. In the next lesson, we're going to talk about list comprehensions. All right, let's take a look at a list comprehension. So a list comprehension is really just a shorthand method of writing a for loop and putting all of that data into a list. Now, we would see an old example like items is equal to something like that. Actually, let's not do items. Let's do numbers is equal to a list of numbers for num in 1, 3, 5, 7, and 9. Numbers dot append whatever that number is going to be to the power of 2. print numbers. And so we see 1, 9, 25, 49, and 81. And so all we did was exponent the number against the number 2. So we said 1 to the power of 2, 3 to the power of 2, 5 to the power of 2, 7 to the power of 2, 9 to the power of 2. You get it. There's a quicker way to do this in Python. This is a very Pythonic thing to do. And it looks very bizarre at first, but instead of doing it the long way, we could say numbers is equal to some sort of value for a value in a list of some kind. And so what we're saying here is, look at this, for loop. And this looks a lot like for num in a list of 1, 3, 5, 7, and 9. And check this out, even when I highlight it, it's the exact same. And all we're doing is returning that value on the left. So now we have num, we can use num instead of x, num to the power of 2, and let's print numbers once more. And let's run this. We're going to see that this is the exact same thing. So now instead of writing 1, 2, 3 lines of code, granted it's only 3 lines of code, we wrote it all in 1 line of code. And so again, we just said the answer for some sort of iteration or iterable in a list of things or a list of iterations, and we have brackets around it. And the brackets around it means that this is going to be a list comprehension. We can do something very similar with dictionaries called a dictionary comprehension, which we'll learn about in the next lesson. But for now, we just need to know that we have a hard bracket here, looks just like a list, and we have some sort of weird stuff in here. Now, what I want you to do is I want you to try this out because list comprehensions are very, very popular in Python. They're significantly more popular than a dictionary comprehension, and you're going to need to know how these work. So when you see it, you don't just look at it and you go, oh, I don't know what this means. I don't know what this is. I don't even know what this is called. You now know that this weird syntax here is your answer for your iteration in an iterable wrapped in a list. And that is identical to what we wrote here. It's just a little bit shorter. So go ahead, try it out. Have some fun with it. Try to break it. Try to understand it. Probably spend like 5 minutes on it and just mess around and see what you can and cannot do. If you want to take this one step further, I would definitely suggest going off and researching how you can add an if statement in here. Because you can have if and else statements inside of list comprehensions as well. So you have one big line with a for loop, and you could have an if statement inside of that for loop and only output something if there is a particular answer. Go ahead, try it out. When you're ready, let's head on over to the next lesson where we learn about dictionary comprehensions. Welcome to dictionary comprehensions. So, like a list comprehension, a dictionary comprehension can be written in one single line as well. So let's go ahead and create a long example, and then we'll recreate it with a shorter example. So let's do an example where we want to create a dictionary out of a list of tuples. And so we can say something like this. Names is equal to, we've got a list and then a tuple in here. Name, Caleb. Occupation, coder. Now to turn this into a dictionary, we'd have something like D is equal to, and then 4, and because this is a tuple with 2 items in it, we can unpack it, so we could say for key value in names, D key is equal to value. And then we can print out whatever D for dictionary is. So Python dictionary. And you can see that's a dictionary now. Name, Caleb, occupation, coder. We could even double check that it is in fact a dictionary, although, I mean, we can look at it by its syntax. But let's see what this looks like. Yeah, it is in fact a dictionary. And so all we did here was create a dictionary from a list the long way. There's a shorter way to do this. So let's go ahead and get rid of that. and I'm going to make this just a little bit shorter so we can see the code. So now we can say D is equal to a dictionary comprehension. So we usually put some sort of key, some sort of value for key value in, let's say, names, which is an iterable. So let's actually write this out the long way. So this is a key, colon, value for every key value in names. Let's go ahead and print out D again, and we're going to see that it's the exact same. It's going to look the exact same top and bottom, just like this. And so all we did here was we opened up and closed with curly braces. We said the key, colon, just like a regular dictionary when we're creating a dictionary from scratch. It then has a value. And then we're saying that key and value are coming from unpacked items in an iterable. Key was the first unpacked item, value was the second unpacked item. And names is the iterable up here. Now, that's a lot easier to write than having to write these 3 lines. You can also add if statements in here as well to make sure that you only add certain information, which I'm going to let you research on your own because that's an important part of learning how to code. But there's also one more way. We could also simply say D is equal to dict names. Check this out. Simple typecasting at its best. So we're going to show up, we're going to print D 3 times, and check this out. We were able to convert names to a dictionary automatically with a single line of code, and we used like 4-6 characters plus a variable name. So there's a few different ways to do this. Now, a dictionary comprehension is not as common as a list comprehension. List comprehensions are wildly popular in Python. Dictionary comprehensions, popular, not as popular. But you're still going to see these and you're going to need to know how these work. So go ahead and give this a try. Feel free to just run this example, lines 1 through 3. You're going to loop through an iterable called a list. And that list is named names. Every item in that list is a set of tuples, or a tuple set. I can't remember what it's called there, but it's got a first value, comma, second value, comma, another tuple, first value, second value. And you can unpack that using key value in that iterable. And then you can create a dictionary comprehension. Then print that out. Make sure that it is actually what you expect it to be. I'm going to undo this code so you can see the long way. Go ahead and try it out. If you get stuck, definitely come check out the Learning to Code Facebook group. We're here to help you learn Python. Let's take a look at how we can get dictionary values. Now, I touched on this a little bit at some point a few lessons ago. But if we have a dictionary, we can check to see if a value exists and get that value by its property name. So let's create a dictionary here called courses. And let's say we have a JavaScript course, a JS course, and it's called JavaScript 101. And we have another course for Python called Python 101. We also have another one called Python 201. So let's make this one a list, Python. And there's also like HTML 101 and all that good stuff. CSS 101. This one's going to be called HTML 101. And so let's say we wanted to get JavaScript. We wanted to get this out of here. Now, we don't necessarily know all the time all the values that come in a dictionary. Typically, we do some print debugging where we do print courses. And then if we see it in there, we can do print course JS. We could do something like that, but we won't always know. And sometimes print debugging, it's okay to do, but it's sort of painful to do at the same time. So there's a better way we can do this. So we can actually say courses.get JS, and you're often going to see this, courses.get JS none. And this is what we're going to see. .get some property name, which matches our line on line 2, our property on line 2. Or a key name. Sometimes we call it property, sometimes it's a key. They're interchangeable terms. Or if there isn't one, set some sort of default. And the default here is going to be none, it's going to be none. And so if we print this out, we're going to see that it gives us JavaScript 101. Now, That's good. That's exactly what we want. But what if we wanted to get CSS? Well, there is nothing in there, so this is going to print absolutely nothing. Just none. It says none in there because there's nothing there. We could also give it a default. Default text in here. And that's going to give us the default text in here. Or, better yet, because we're going along the sort of pattern of JavaScript 101, HTML 101, Python 101, etc., we could do CSS 101. And so if it can get CSS 101 out of this dictionary, great, it's going to. Otherwise, it's going to default to CSS 101. When we print this, we're going to see it says CSS 101. And that's because CSS as a key, as a property inside of this dictionary simply does not exist. So it falls back to CSS 101 or whatever we decide to give it. Now, where this is useful is if I comment that out, we can say if courses.get CSS, and we're not going to give it none because that's what the default is. We can simply say print you are enrolled in, if I spell that right, enrolled in CSS 101. Now, watch this. This is not going to print anything. It does absolutely nothing. What if we say if courses.get and gave it some sort of value in here, CSS 101? Is this going to execute? And this is a good question to be asking yourself. It says you are enrolled in CSS 101, and that's because it couldn't get that CSS value, so then it went and set a default one. And this is a lot like saying if a string is equal to CSS 101, which is often why you're going to see this. And this is just a little more explicitly written. So this is going to say if courses.get CSS, if there is one, cool, execute this if statement, otherwise none. And we know in conditional statements with Python that if you say if none, this is going to be the same as saying if false. It's not going to execute. So when we try this out again, it's not going to print anything. We can do this over and over and over again. Literally just prints nothing. Now you're going to see this all the time, nonstop, probably every single day as a professional Python developer. What you want to do as your task, or what I would like you to do as your task, is get a little hands-on experience with this. Go ahead and create a dictionary. And in that dictionary, I want you to go and then use .get, and then one of the key values, and give it a default. And just play with an if statement. Basically, just do exactly what I did in this video. Even if it only takes you 30 seconds, you might think, oh, well, this is meaningless. But really, you're building up a lot of muscle memory here. And what's nice about muscle memory is as soon as you see it, as soon as you start typing it, eventually at some point it just becomes second nature. You don't have to think about it. It just happens. You just know Python. Go ahead and try that out. In the next lesson, we're going to talk about something a little more complicated called a virtual environment. All right, let's talk about virtual environments. A virtual environment is a way to compartmentalize packages. So for instance, I can use pip to show my packages. I can say pip show Django, and I have Django installed here. I'm using Django 2.2.13, and that's on my computer. Now, what if I have a project that's using a different version of Django, say Django 3.1? And then let's make that one step more complicated. What if I have 5 different websites using Django, but they're all using different Django packages? Currently, what I would have to do is pip uninstall Django and pip install Django is equal to 3.1 point whatever. And I'd have to do that over and over and over again. And you can actually see when I'm using pip show Django here that it shows you exactly where Django is. And this is right on my computer. It's in library frameworks, Python framework versions 3.8, lib Python 3.8, site-packages. That was a mouthful. But what if you have, a project, let's say a Django website again, where you want to share this with everyone else in your company, and you want them to use Django as well. Well, instead of packaging up Django and shipping it with your website and sending it to everyone, it's like zipping up a file and sending it to everyone. You can just simply tell them to pip install Django using a certain version. And we do this, and we separate these different versions, or we separate these different environments, or these projects, using a virtual environment. And this is a very, very common thing in the world of Python. And so to get into a virtual environment requires one of two things, one of two steps rather. Either you're going to be on a Unix-based system like Mac OS or Linux. They're very, very similar. Or you're going to be on Windows. I'm going to show you how to do it on both. So to create a new virtual environment, first of all, let's do ls-la, or if you're on Windows, you can type dir. And if I scroll up here, usually you're going to see a folder called .venv, or just venv, or env. These are the three most common I have seen out there. So we don't have any of those yet. Let's go ahead and create that. So we can do python -m-venv.venv, and that's the folder we're going to put it in. And it's going to take a second, do a bunch of thinking. VS Code was smart enough. It said, we noticed a new virtual environment has been created. Do you want to select it for this workspace folder? Yeah, okay, might as well. You can see over here, I've got a venv folder. If I do ls-la or on Windows dir, scroll up, I now have a folder in here called .venv. I also have a VS Code one. That's just VS Code being VS Code. We don't have to worry about that. But I've got a venv folder in here, and it's got bin, lib, include, pyenv.cfg. If you're using pyenv, which I am, you might not have that. But that's how we create a virtual environment. Very simply, it's just python -m venv.venv, or whatever you want to call that folder. I usually call it .venv, so it's hidden. And we try not to commit these to our Git repositories. Now, that's all well and good, but if I do pip show Django, it's still using the exact same location. It's still using the exact same version as before. We're not actually using our virtual environment. We have to get into it. So we created it, but now we have to get into that virtual environment. So if you're on Mac or if you're on Linux, you can type source.venv bin activate. And you can see it says .venv over here. I'm in a virtual environment now. Now watch this. If I do pip show Django, nothing shows up. It's not installed in our virtual environment. And what's cool about this is I can do pip install Django. And I'm going to give you Windows instructions to get into your virtual environment as soon as this is done. So this is just going to go off, download Django, pip show Django. And this is now using Django 3.1.4. It's in my Python 201 folder in the .venv in its library, Python 3.8 site packages. Cool. So let's get out of this. We get out of this with deactivate. And that just got me out of my virtual environment. Now to get back into the virtual environment, if you're using Windows, this one is a little bit trickier. Typically we do something like \venv .scripts .activate .bat. Now this highly depends on your operating system. If you create a virtual environment in venv, it's going to be in .venv right in here. Otherwise, what you're often going to see is /env scripts with a capital S activate .bat. And that's how you get into your virtual environment using Windows. It's going to be one of those two options. So let's get back inside here. I'm going to do it the Mac way. So source.venv bin activate, and now I'm inside of it. Pip show Django, and this is going to show me Django 3.1.4 right there. Deactivate to get out of it. Pip show Django again. And my computer is using version 2.2.13. So my computer has access to Django, but it's an older version of Django. My virtual environment, which is brand new, has a brand new version of Django in it. And so now I can use two different versions of Django or any Python package and make sure that, they're not going to conflict. I can have another virtual environment on another project using a different version of Django. And so the whole idea here is that if you have multiple projects on the go, it's really, really easy to just upgrade one project and not have to worry about upgrading another project. Because if you upgrade one project and you have to upgrade all your other ones, that's going to suck. I have over 200 websites on my computer from my job right now. And I could not imagine having to upgrade Django on 200 sites every time I wanted to do a little bit of a version bump. And so this just keeps it nice and simple and separated for us. So typically whenever you're working on some sort of Python project, you are going to create a virtual environment. It's always a good idea. Even if you only have one project on your computer, make sure you create a virtual environment. And again, that's just python-m venv.venv, and then it's going to be source.ven bin activate, or if you're on Windows, it's going to be .venv scripts /activate.bat, and that's going to get you in. And then once you're in, you simply type deactivate to get out of it. Go ahead, create a virtual environment, and then get inside of it. Do something like pip install Django, and then deactivate it. Once you have that virtual environment up and running, you've been able to enter it and exit it. Perfect. Let's head on over to the next lesson where we talk about a better way to learn Python using a new type of Python shell. Let's take a look at how we can learn Python in a more interactive way. So we can always go into Python and we can create some sort of object and then hit dot and then tab, and it's going to show us all sorts of methods on it. So for example, we can have a string called name. We're going to call this Python201, and then we could do name dot, hit tab a couple of times, and we can see all different things in here. For example, we could capitalize this. It's already capitalized, that's not going to do anything. Name dot ends with, we could do 201, and this is going to return true for me. And so we can see all these different things in here. We don't have to do it with just a string either. We just happen to be doing it with this string. We can do it with a tuple, a dictionary, a list, pretty much any data type that has some sort of transformation on your data. You can do this with. So for example, if I wanted to put this into words, we could do name dot, and then where are you? It's called split, right there, split. Name dot split, and we want to split it on every single space. Now it looks like it did nothing, but words is now a list. We could do words dot reverse, and let's take a look at this. Words dot, hit tab a few times, reverse is at the very end, reverse. It's backwards, and now we can join this back together, and then we can put this back together by saying course is equal to a string dot, and we had up here in string join. How do we want to join these together, or what do we want to join together rather? Words. And so we're saying use a space to join all the words together. Course. And now I just reversed all the wording in a course. Now it's, instead of saying 201, or instead of saying Python 201, it says 201 Python. And this is a really, really, really powerful way to learn how to code. So if I clear that out again, what we can do is words, I've got 201 and Python in there. Words dot, let's pop. That returned the word Python, and if I do words, I only have that one word in there. I can do pop again. It gives me that last word, 201. Words is now an empty array or an empty list. If you have some sort of dictionary, you can always do a dictionary dot and then hit tab a couple of times. Make sure it's an actual dictionary, so have a proper value in there. But then you could do your dictionary dot tab, or tab a couple of times sometimes, and it'll show you everything you can do. So what I want you to do is I want you to create a tuple, hit dot, then hit tab, and then I want you to see what kind of things you can do with a tuple. And then I want you to do the same thing with a list, because lists and tuples are almost the same thing, but tuples aren't really mutable. You can't really do a lot with a tuple. And I want you to compare the differences. And then just explore. Feel free to explore. The worst you're going to do is a little bit of damage to your variable. Not your computer, not your virtual environment. Everything else will be totally fine. You're just going to transform your variable. That's all you're going to do. And this is a very, very, very powerful way to learn Python, Django, Flask, really anything Python related like Wagtail CMS, anything, really, you're going to be able to do it. You're going to be able to learn it a lot faster this way. And that's because simply a course should not go over every single item in here. For example, name dot. I'm not going to teach you format map or is numeric or is printable or partition or anything like that because there's just too many options. Same with a list. There's a lot of options in here. Now, this doesn't sound like a lot of options, but imagine what you can do with a dictionary. Imagine what you can do with a class. Imagine what you can do with a tuple or a set. And having to go through all of those one by one is, honestly, it's painful for you to watch. It's also painful for me to teach. And frankly, you're not going to use most of them. So whenever you see some code in the wild, let's say you're working with a senior developer, and a senior developer has some really fancy code, and you're like, whoa, what does words.extend do? Well, now you know that you can go and experiment with words.extend, or list.extend rather. Now, this is one way to use your shell, and that's just simply typing Python. That gets you in there. Another way is you can use IPython, and I really, really like IPython. So I do pip install IPython. Clear. And instead of typing Python, I simply type IPython. And you can see it's a little nicer in here. Name is equal to Caleb Tallien. Name, dot. Hit tab a few times, and now I can actually move through these, and it types it out for me. You can copy and paste a lot easier in here as well. You can do multiple lines. You can do all sorts of stuff. And this is an even better way to explore because it's a little more interactive. It's easier to be like, oh, what is zfill? Takes exactly one argument, 0 we're given. Let's fill it with a 1. Let's see what happens. String cannot be interpreted as an integer. Okay. Cool. I have no idea what zfill does. I'm going to go and explore that after this this video is wrapped up. So fun. That's how we learn. And that's how you can learn on your own, so you don't need to take another Python course or another full stack web development course or watch another hour-long tutorial on zfill. You can explore it yourself and then figure out what you need to learn from there. So you're maximizing your time by doing your own exploration and getting your own experience. In the next lesson, let's go ahead and talk about packages. Let's talk about packages now. Okay, so we have this idea of a package, and we've dealt with this a little bit. We did pip install IPython. That's not how you spell Python. IPython. We did pip install Django. We even at one point did pip install Colorama, and we're going to do pip install Colorama again. But first, we're going to get into our virtual environment. So if you don't have one, python-m venv.venv. Cool. Source.venv bin activate. I'm now inside of my virtual environment. I can now do pip install Colorama. And I know that Colorama is a package that we can use, and it's going to go and install it. Cool. It says successfully installed Colorama 0.4.4. Now let's go and take a look at some of the documentation here. Colorama on PyPy. And this is where you can find any sort of package. PyPy.org, you can search for anything. So for example, if I wanted Wagtail packages, you could find different Wagtail packages in here. If you wanted to find Django packages, you could literally just type Django, and it'll find all sorts of Django packages for you in here. The one I'm going to use is Colorama. Colorama 0.4.4. And it tells us how to install it. That's great. Now, how do we actually use it? And it tells us in here, applications should initialize Colorama using Colorama import init, and then actually instantialize that init. Okay, so let's go ahead and do that. So let's go into our regular Python shell, not a IPython shell, just a regular Python shell. And actually what I'm going to do is I'm going to change my mind on that. Instead of using regular Python shell, what I'm going to do is use IPython because we installed it, might as well use it. From Colorama import init, and then we wanted to run init. Okay, cool. It looks like it did nothing, but we're following the instructions so far. How to get colored output? So let's go ahead and let's honestly just copy and paste this. Copy that whole thing, paste the whole thing in there. And look at that, we have some red text, we've got text with what presumably outside of IPython would have been a green background. Some dimmer text and normal text in here. So all we did here was we said import for back and style. We said foreground is going to be red. The background here is going to be green with some green text. Then style dim, we're going to dim that text. Style reset all of it, and it's back to normal. That's all we did. And so to use a package, we really just do pip install the package name. From that package name, import something. Now we don't know what exactly we can import, and that's why it's so important to read the documentation. And it tells us all sorts of things that we can do in here. Now, this is kind of an ugly example, so let's go ahead and run this in our regular Python shell. Let's do python-v. I'm using Python 3.8. You can also try it just in your regular Python shell. It's probably going to turn out better in your Python shell, but what we can do instead here is we can let's import this. Let's do from colorama import init. Then we need to instantialize init, and let's go ahead and save this as packages.py. And I'll make this a little shorter here. And what I'm going to do is move all my imports to the top of the script here. We can actually even merge this together. We can say from colorama import init for backend style. Let's go ahead and run this now. So let's save and let's run this in Python. And there we go. It says some red text and with a green background. That's actually a super light green background. So maybe IPython was right and I just can't quite see that. It's super dim. We're keeping the dim red text with a green background. Then we're resetting it back to normal. And we're running all of this inside of our packages.py script. And so that's really all there is to a package. Remember, all you have to do is pip install the package name. And then we do from package name import thing 1, thing 2, thing 3, and we just follow the documentation. And the key here is really follow the documentation. Even on PyPy here, I typically don't even follow documentation from PyPy. I typically go straight to GitHub. GitHub. And this is going to tell me, I think this is the exact same, so great. But it also tells me other things like available formatting constants are for foreground, black, red, green, yellow, blue, magenta, cyan, white, reset. Background, same thing. Style, we can dim, normal, bright, or we can reset all. So what I would like you to do is pip install Colorama, go to this Colorama GitHub page, read through the documentation, make sure you import Colorama and import init from Colorama, run init, and then basically just copy and paste this. That's what I did. And just have some fun with it. Because now you can make your terminal look nice and colorful, which is amazing because terminals are notoriously boring. Now you're going to be using packages all the time, nonstop, every single day. You're going to be importing things every single day. So it's important that you know how to use packages. Go ahead and try that out, and when you're ready, let's head on over to the next lesson where we do a little API requests refresher before our final project. All right, welcome to the API requests refresher lesson. What we're going to do here is just a quick little refresher on API requests. So if I open up making JSON API request.py, let's go ahead and take a look at what we originally wrote. And so we're not going to do any coding in this video. We are simply going to go over how this works. So request is a package, we import it, and just like in the last video where we imported Colorama, we imported requests. And with that came an object, or a method, called get. And so we do req, this could be anything, is equal to requests.get, and then some sort of URL. And that's just going to fetch that data for us. Then if that data is JSON, we're simply going to say that request object dot read the JSON. And what that does is it turns that JSON into a Python dictionary, which we can use later. So in this example, we were using, I believe this was C3PO, and this is now a dictionary, and we can print person name, because name is a property or a key on the person dictionary. Birth year was also available, so we put person birth year, just like a standard dictionary. And it's because this is coming in as JSON, which technically is just a string, but it's formatted a certain way, and Python recognized that and turned it into a dictionary. We also said for every film that this person was in, for every film C3PO was in, make a new request to that film. So this was a list of films. And so this is going to go through every one of them. I think there was like 7 of them or something, so the data wasn't completely filled out yet. But then we said, for every film, go ahead, get that film. Then we said, overwrite that on every iteration, so overwrite film. And because we know it's going to be JSON, transform that JSON into a dictionary called film. And then we said the film is, and then the title. And we got all of that from swappy.dev. Now in our final project, we're not going to be using swappy.dev. We're going to be using pokyapi.co. So it's very, very similar, but instead we're going to use something with a little more information. And so you can see that this has like a lot of different dictionaries in here. So ability is a dictionary, but this has a list of abilities in here. So this is a list, and this is just a standard key value pair. So we're going to be working with a little bit of a more, I guess, an advanced API, but we're going to be using things in a simple way because Python keeps things simple. So for this video, instead of doing any coding, what I would like you to do is go to pokyapi.co and just read through it, experiment with it, click around, try to break things. Even if you're not familiar with Pokemon, it's totally okay. We can just use some base examples from what they provide us. Because in our final project, what we're going to be doing is using this API, and we're going to be fetching a bunch of different information. So go ahead, get yourself a little bit familiar with the Poke API. Don't feel like you have to write any code. We're going to do this as our final project. The code part is going to be our final project. When you're ready for that final project, and maybe set aside like half an hour to watch the video and work on the project, but once you have that time set aside, let's head on over to that next lesson, the final lesson, where we create a Pokemon character app. Let's take a look at our final project. Our final project is going to be creating a Pokemon character app. So in this, what I would like you to do is, let's write out some instructions here. 1, I want you to ask for user input. So for example, ask for a Pokemon. Which Pokemon are we going to talk about? That could be like Ditto, for example. Then you're going to need to create an API string, an API URL. A lot like this, where it says, we can go straight here and gives us all the information. We're just going to take that URL, but we're going to change out Ditto for whatever the user input. So step 2 is going to be create a dynamic URL based on step 1. Number 3 is we need to then fetch that data using requests. So step 3 is fetch the data from the URL in step 2. Step 4 is going to be print out the JSON data. But because it's JSON, we can't actually print it out. We need to convert it. So step 4 is going to be convert JSON to a dictionary. Step 5 is then going to be print out some Pokemon data. So print out Pokemon data. And that data is going to come from, for example, here. So it has abilities, it has forms, it has base experience, game indices, a height, held items, moves, IDs. It has all sorts of stuff in here. So I'm going to leave that up to you, to whatever you want to display. So I have now walked you through basically the exact steps you need to create some form of Python program that can accept a Pokemon as a string, and then you can go and fetch that data from an API and display it in your terminal. What I'm going to do here is I'm going to save this as project.py, comment this out, and I'm going to then show you how I go about doing this exact project. But I want you to give this a shot first, so please do me a solid here and just pause the video and try this out on your own. Feel free to reference these instructions again, but try this on your own. Try to make your brain sweat. Try to leverage what you've already learned in this course without having to watch the rest of this video. Now, our solutions guaranteed are going to be very different, and that's okay. There's a million different ways to do the same thing in programming. If I write this versus my mentor writing this, we're going to get different code anyways. And your code is going to look different from mine, but that's not the point. The point is you give this a shot. Try this out to the best of your abilities. Now, if you get stuck, that's okay. If you get stuck, you can just simply resume the video and you can see exactly how I do it. So I'm going to fade out and fade in, And when I fade out, I want you to pause the video and try this. Good luck. Don't forget to have some fun with this. This is a really good use case of Python and APIs. You're going to need this in web development and all sorts of Pythonic stuff down the road. All right, let's go ahead and finish up this project, or I guess start the project and then we'll finish it up. So first things first, step number 1, we have to ask the user for input. So we're going to say the Pokemon is equal to input. Which Pokemon do you want to find? And then we're going to say Pokemon is equal to Pokemon.lower. And we know that we have to do .lower and reassign this because strings aren't mutable. We have to basically take that value of Pokemon, whatever the user writes, lower it, and then jam it back into another piece of memory called Pokemon. Just happens to be the same name here. So that's where mutability versus immutability comes in. Then we need to create a dynamic URL based on step 1. So that URL is going to be this URL right here. Copy. Throw that into a string, but it's not always going to be ditto. We need to change that. So let's change that to Pokemon. And let's make that an F string. So that's step 2. Step 3 is to fetch the data from the URL in step 2. So we can say req is equal to request.get the URL. And when we use request, we have to then import requests. Request. And that's actually plural. It's supposed to be requests. So we use requests.get, then the URL. And that's step 3. Step 4 is to convert the data to a dictionary. So then we can go down here and we can say that data is going to be whatever that request is, .json. We know it's coming in JSON form, so we can use .json on it. That's step 4. Step 5 is print out Pokemon data. So what do we want to print out? Let's print out the name that we found. So we can say print name is tab, and then whatever that name is going to be, data name. And if you're wondering where I got name from, data is now a dictionary, or at least in theory it's a dictionary, and name is coming from this little fella right there. Let's make this bigger, right there. And let's maybe see what kind of abilities it has. So this is a list. We can see that it's a list, and it has a list of dictionaries in it. So let's go ahead and look at the abilities. So then we can say print abilities is going to be something we don't know yet. And let's just loop through those. For ability in data abilities, we can loop through this because we know that this is a list. And so this first ability is going to be limber, and the second ability is going to be imposter. So then we can say print ability, and this is a dictionary as well. So for every item in this list is going to be a dictionary. And then we've got one called ability, which is also a dictionary. Ability. And then we want that name. And let's go ahead and give this a shot. Let's see what happens when we run Python project. I don't even know if I have typos. I haven't even looked for typos. Which Pokemon do I want to find? Let's look for Ditto. It has Limber and Imposter in there. Cool, cool, cool. Okay, what other Pokemon do I actually know? Charizard. Its abilities are, and let's just move this up. I found Charizard. Its abilities are Blaze and Solar Power. Cool. If we wanted to get more information, we could actually get that URL and make a request there as well. And we could see what kind of ability it has. And it has different language settings. How cool is that? So we've got an English language. The first one is a German language. Flavor text entries. I don't even know what that is. That's beyond my knowledge of Pokemon. But anyways, we can, if we wanted to, grab that URL for more details about what that particular ability is actually going to do. So at this point, we're pretty much done. That's all we have to do. But what happens if you type in a Pokemon that doesn't exist? Oh no, we get a problem. And this is interesting because, where are we here? JSON decoder error, expected value line 1, column 1 carry. It's basically saying that JSON is not formatted properly. So what we can do here is we can wrap all of this in an if statement. If rec dot status code is equal to 200, that means we're getting a healthy status code. We can take all of this stuff, make that just a weensy bit tinier there, and outdent that. Otherwise, we can print Pokemon not found. And so now we're dealing with proper status codes here. Let's go ahead and try this again. Let's write a bunch of junk in there. It says Pokemon not found. And so it went off and went to wherever that is. That's not a Pokemon apparently. And so Pokemon wasn't found. Let's make sure that the status code is actually supposed to be 200, because sometimes it's 201. Who knows? Which Pokemon do I want to find? Bulbasaur. And look at that, that came back really fast. Name is Bulbasaur. Abilities, Overgrow and Chlorophyll. Cool, cool. Now that's really all there is to this project. Now, if you want to take this one step further, what you could do is you can make this always ask for more user input. So let's do that. Let's always ask for more user input. So what we're going to do here is we're going to wrap this in a loop. We're going to say while something is true, put all of that inside of this while loop. And it's always going to ask for a Pokemon. It's always going to make a request. And then when it's done, it's going to ask for another Pokemon. And that's literally all we have to do to make this a permanent or a proper Pokemon lookup tool. So let's go ahead and type python project.py. Let's look up Ditto. Okay, it found Ditto. What about Charmeleon? Cool. What about one that doesn't exist? Does not exist. It says Pokemon not found. And it just keeps asking over and over again. And if I ever want to quit, I can always just do Control-C. And that gets me out of that while loop. So now we have a program that's going to constantly ask, which Pokemon do you want to find? This is a great way if you ever wanted to build an app down the road, like a Pokemon finding app or a Pokemon information app. This is exactly what you would do using Python. So that was my solution to this particular project. Your solution might be a little bit different. Your solution might be a little more simple or might be a little more complex. That's completely up to you. What I want you to do, if you haven't done this, is I want you to now try this out on your own. Don't reference my code. Try it out on your own and just see how far you can get. Make your brain sweat. It's important to make your brain sweat. It's supposed to feel like a little bit of a struggle. And, you know, if you get really, really stuck and you're just like, I just don't know what to do, either consult Google, because honestly, half of programming these days is just Googling stuff. And if your own research doesn't get you anywhere, then reference this code. And that's sort of going to move you away from being tutorial dependent like this video is. This video is very tutorial style, and it's going to sort of move you into the realm of figuring out how to solve your own problems, which is really, really, really important, because coding is all about solving problems on your own, and you're not always going to have a teacher, so you need to be able to do this on your own. I hope this was enjoyable for you. I hope this was a fun little project using APIs and all this good stuff. We use a lot in here. We used a while loop, we used a package, we used input, lower, so mutability versus immutability, an F string. We used an API request. We checked the status code, so a conditional. We turned code into a dictionary from JSON. Then we printed with tabs using more F strings. Then we looped through every ability and got the ability name. Kind of cool. So that was nice and short. That was actually a pretty fun small project. Go ahead and try that out if you haven't. Last but not least, I would like to say thank you for taking this course with me, your teacher, Caleb Tallien. This has been a lot of fun. I'm very proud of how far you have gotten. Don't forget, writing code is all about practice. Just practice, practice, practice. Just writing code, solving more problems. Writing code, solving more problems. That's all it is. Over and over and over again. Once again, I know there's a lot of different Python courses out there, but you chose mine, and I really, really appreciate that. So thank you for giving me, of all people, a little bit of time from your life. I really appreciate that, and I hope you get to build some really cool things in Python in the future.